Good morning, all two of us.
Good morning.
Look at verifying identities Monday, right? Just using trig identities to simplify stuff. The point of that was to lead into proving some of the more well-known identities. Obviously, I don't prove them in class, just watch the video. They're all derived in the video. First one to look at are the sum difference identities. There were three groups formed. There was a group for cosine, group for sine, and group for tangent. Right. All real numbers, alpha and beta. Cosine of alpha plus beta. Cosine of alpha times cosine of beta minus sine of alpha times sine of beta. And cosine of alpha minus beta is the same except it's a plus instead of a minus. Again, I would recommend you write these down on that separate sheet of paper with all of your important properties and identities. And for sine, again, all real numbers alpha beta. Sine of alpha plus beta. Sine of alpha times cosine of beta plus cosine of alpha times sine of beta. Sine of alpha minus beta is the exact same, except it's a minus instead of a plus. And finally for tangent, all real numbers. Alpha and beta tangent of alpha plus beta. Tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Tangent of alpha minus beta is the same except plus and minus are reversed. We find exact values, sine pi over 12, cosine pi over 12, tangent pi over 12. There are actually two ways we can do this. Unfortunately, we don't have the half angle identity yet. So I could also use the half angle identity on this. And when we study that next week, I might revisit this. The idea, and if you look, pi over 12 is still not on the unit circle. It doesn't show up. So then you want to ask yourself, can you write this as the sum or difference of angles on the unit circle? Because if you can then use the sum difference identity to find an exact value. Pi, 4 pi minus 3 pi, right? What's 4 pi over 12? So it's 4 over 12? Other way. 1/3. 1/3. Isn't pi over 3 on the unit circle? Yeah. What's 3 pi over 12?
1/4.
Isn't pi over 4 on the unit circle?
Yeah.
There's our difference. We can now use the difference identity. Sine pi over 3 times cosine pi over 4 minus cosine pi over 3 times sine pi over 4.
A question. In the test, you're going to give us again the sheet with the circle and values?
I'll give you the unit circle one, yes. What's sine pi over 3?
Square root of 3 over 2.
3 over 2. What's cosine pi over 4?
cosine 6, right?
Cosine pi over 4.
Square root of 2 over 2.
Cosine pi over 3.
Wait, you said cosine of pi over
4.
what?
Yes. Oh, 2 over 2.
What is it? Oh, yeah. Yeah.
1/2
And sine of pi over 4.
square root of 2 over 2.
What's root 3 times root 2? Just root 6. Remember, square roots, that does distribute across multiplication. Square root of 6 minus square root of 2 all over 4 is the value of sine pi over 12. That actually can be simplified. It's also written in the form root 3 minus 1 all over 2 root 2.
But if we leave it like
Yeah.
differently,
Yeah, it doesn't matter. Cosine the difference identity. And then cosine pi over 3, the order doesn't matter. Cosine pi over 3 times cosine pi over 4 plus sine pi over 3 and sine pi over 4. And we already said what those values were. Just so it's symmetric with sine, I'm going to write the root 6 first, but it doesn't matter. Root 6 plus root 2 all over 4, and using a similar argument, root 3 plus 1 over 2 root 2. Tangent. Let's use the identity on tangent, not sine over cosine. the tangent of pi over 3 minus tangent of pi over 4 over 1 plus tangent of pi over 3 times the tangent of pi over 4. What is the tangent of pi over 3?
Square root of 3.
Just root 3. What's tangent of pi over 4? This is the easiest one.
1.
It's just 1. Pi over 4 sine and cosine are equal, which is nice. And then over 1 plus root 3 times 1. And also, again, make it symmetric. Root 3 minus 1 over root 3 plus 1. Which you can easily see, right, if you do, there's sine. There's cosine. Sine over cosine. You'll get root 3 minus 1 over root 3 plus 1. Once you fully simplify. Pi over 12. And again, remember the goal is, since you know pi over 12 isn't on the unit circle, write it as a sum or difference of angles on the unit circle. Or some difference of angles that we just did, which we're not going to be able to do that. Actually, I could do 4 pi plus pi, which would be pi over 3 plus pi over 12. We just did pi over 12, but that's kind of hideous. Again, we could also use the half angle identity, so I'll probably revisit this when we look at the half angle identity. 3 pi over 12, pi over 4. What's 2 pi over 12? It's 2 over 12.
Pi over 6.
Be pi over 6. And pi over 6, is that on the unit circle?
Yeah.
Yes. So this would be the easiest sum to use. Again, you could do pi over 3 plus pi over 12 as well. Because we just did pi over 12. Some identity on sine. This will be sine of pi over 4 times cosine pi over 6 plus cosine pi over 4 times sine of pi over 6. We already did sine pi over 4, right? What did we say it was? 1 plus.
Root 2 over 2.
Root 2 over 2?
Yeah.
What about cosine of pi over 6?
Root 3 over 2.
That's root 3 over 2. What was cosine of pi over 4?
Root 2 over 2.
What is sine of pi over 6? Wow. Root 6 plus root 2 over 4. Oh. That's cosine of pi over 12. That's because I could have also used 5 pi over 12 is pi over 2 minus pi over 12. Then that comes into the co-function identity.
Bless you. Thank you.
So once again, co-function identity is verified. Which means you should know what cosine of 5 pi over 12 is going to be before we even do it. Should be that, right? So let's just verify that. Really? Already?
Roughly such that big too. So the answer would just basically be the same. You just switch the sign, right? So it would be pi over root 6 minus root 2 over 4.
So that force remove fiction. Right, some identity for cosine. Cosine pi over 4 times cosine pi over 6 minus sine pi over 4 times sine pi over 6. Right, we already did all these values, right? 2 over 2 times root 3 over 2 minus root 2 over 2 times a half. Root 6 minus root 2 all over 4, or simplified to root 3 minus 1 over 2 root 2. We should also know what tangent's going to be. But again, we'll just verify it. Saving. The sum identity for a tangent. I'm going to get tangent pi over 4 plus tangent pi over 6 over 1 minus tangent pi over 4 times tangent pi over 6. What was tangent of pi over 4?
1.
What is tangent of pi over 6?
Root 3 over 3.
Which I'm going to write as 1 over 3 for our purposes. Declare a complex fraction, compound fraction by multiplying numerator and denominator by root 3. Root 3 plus 1 or root 3 minus 1, which is what you should have expected. We want to rewrite this expression as a single function of an angle. It doesn't want us to evaluate it, we're just rewriting it. Which means you have to recognize the identity. Well, if you look, it's mixed, right? Sine, cosine, cosine, sine. That should immediately tell you it's a sine. So it's going to be sum or difference of sign. The question is which one. We just look back at our identities and we go, oh, it's the minus. Okay. So it's going to be that sine of 75 degrees minus 28 degrees. And what is 75 minus 28?
Why is sine 75 minus 28?
Yes, that's the difference identity for sine, right?
Yeah. Right.
So it's alpha minus beta. And what is 75 minus 28?
What is that?
47 degrees. Sine of 47 degrees. There you go. That's all we have to do. Cosine times cosine minus sine times sine. That's going to be the cosine, one of the cosine identities. And you can actually tell which one it is just by looking now at that middle sign. It's going to be the sum identity. Cosine switches it. That's cosine of alpha plus beta. $31 and $48. $79.
Wait, why don't we use the sine? I don't get it.
So you want to look at which one does that look like. Because it's cosine times cosine and sine times sine, you know it's going to be one of the cosines.
Okay, and why the first one we use sine? Because it was sine, cosine, and...
Right, because sine knows in the identities it mixes them. Right, it's a sine times cosine and a cosine times sine. If you look at the cosine,
Okay.
the cosines stay together and sines stay together. So that's a good way to distinguish the two.
Okay.
Sine mixes them, cosine keeps them together. And then with cosine, the identity is opposite of the sign that you're using. Whereas sine keeps the same, right? So if it's a plus, you know it's the sum identity. If it's a minus, it's the difference. Right, and obviously if you see tangents involved, you're going to be using one of the tangent identities, right? So this is just that's just a little trick that I use to know which identity I'm using. That way I don't have to memorize them. Oh, here we go. Speaking of tangent, this one's clearly a tangent identity. But which one? Sum or difference? Again, you can tell just by looking at the sign of the numerator. Numerator keeps the same, so this is the sum identity for tangent. Tangent of alpha plus beta. $37 plus 68. $30 and 60 is 90. 7 and 8 is 15, right? 90 and 15. 105. That's tangent of 105 degrees. Okay, look, proof. So this is going back to what we were doing last class. Right, verifying an identity, establishing an identity. Except now, we have 6 new identities we can use. We have the sum difference identities for sine, cosine, and tangent. Use the sum identity for sine. Sine of alpha, cosine of beta, plus, right, remember, the sine identities keep the same operation. Cosine of alpha times sine of beta. And so that's how that one breaks down. Minus, I'm going to do a quantity. Now use the difference identity. Sine mixes your sines and cosines and keeps the operation. Sine alpha, cosine beta, minus cosine alpha times sine of beta. All right, so there's your second term breaking down. But now look at what we have. We have a sine 45 cosine theta minus a sine 45 cosine theta, right? They would just sum out to 0. Cosine 45 sine of theta minus a negative cosine 45 sine theta. So they double. Right? They add together. What's cosine of 45 degrees?
Root 2 over 2.
And you get root 2 sine of theta as desired. Another proof. The sum identity on sine again, remember sine mixes your two and keeps the operation. Sum identity for cosine. So the cosine, it keeps your cosines and sines together, and the operation is the opposite. This would give us cosine of alpha, cosine of beta, minus sine of alpha times sine of beta. Cosine of 60 is the same as sine of 30. Using the cofunction identity, right? 90 minus 60 is 30. And the same argument, sine of 60 is the same as cosine of 30. Then you have a cosine 30 sine theta minus cosine 30 sine theta. They sum to 0. And what we're left with is twice sine of 30 degrees times cosine of theta. What is sine of 30? So what we're left with is cosine of theta as the standard. oversimplified. Right, the goal is we don't want sines and cosines of multiple angles. Again, use these sum and difference identities on sine. You know what sine of alpha plus beta is. Right, there it is. Plus, and we know what sine of alpha minus beta is. And again, you notice, look, cosine of alpha sine of beta minus cosine of alpha sine of beta. They add out to 0. And we're left with 2 sine of alpha cosine of beta. By the way, this establishes an identity. Right, so much like what we did here, although it's not really useful, but we just established an identity. That would now be an identity you can use. The sum identity for cosine remember, the cosine switches your operation. Then the difference identity. Again, cosine alpha, cosine beta minus cosine alpha, cosine beta. They sum to 0. We're left with -2 sine of alpha, sine of beta. Once again, that's now an established identity. So again, that would be an identity you would now be able to use. tangent of alpha plus beta minus tangent of alpha over 1 plus tangent of alpha plus beta times tangent of alpha. I'll do this. I can change a variable to make it even easier. Replace alpha plus beta with gamma.
Why?
Just to make it easy.
easier.
Don't have to if you can see it right away, but this just makes it more obvious. That's a difference identity on tangent. That'd be tangent of gamma minus alpha, right? Replace gamma. Aren't you just left with tangent of beta? And the reason I did that change of variable is you might be tempted to use the sum identity to rewrite tangent of alpha plus beta. Which, yes, you can do, but you're going to have a lot more algebra to get the tangent of beta. This one just looks hideous. What you could do is expand each of those terms, right? Well, why don't we try to do this instead? That first grouping, isn't that the difference identity for sign? That'll be sine squared of alpha minus beta plus that second grouping is not the difference identity on cosine? Again, just to make it more obvious. Do a change of variable. Called gamma, alpha minus beta. Well, then we have sine squared of gamma plus cosine squared of gamma. What does that equal?
Sine to square of gamma plus cosine to square of gamma.
Hmm?
What is the question? Sine square of gamma.
What does sine squared of gamma plus cosine squared of gamma equal?
One.
1. So this is what our expression equals. 1. I will not write that out as London because I don't know how useful that one will be. So we're given that sine of alpha is 4/5, cosine of beta is 5/13. Both alpha and beta are located in quadrant 1. Find sine alpha plus beta, cosine alpha plus beta, sine of alpha minus beta, and cosine of alpha minus beta. And just for fun, we'll also determine what quadrant alpha plus beta is in and what quadrant alpha minus beta is in. Let's set our two triangles. Right? Both alpha and beta are acute angles, so we can safely use right triangles. What is sine in terms of right triangles?
Opposite over hypotenuse.
What is that missing length here? Which is what? What is the length of it? That was simple. It's a 3, 4, 5 right triangle. What is cosine?
Adjacent over hypotenuse.
What is that missing length?
I don't know. Can be a variable, yes.
It has a fixed value. How would you find it?
Pythagorean theorem.
What's 13 squared?
109.
It would have to be greater than 12 squared. Right? So what's 12 squared?
199.
We could also do this, I suppose. 10 squared is 100. 3 squared is 9, right? So that's 109 right now. What is 10 times 3?
30.
Double it.
60.
Add it to 109.
169.
So what's 13 squared?
169.
169 cubic. What's 5 squared?
25.
169 minus 25. $169 minus 20.
144.
169 minus 25 is 144. What's the square root of 144?
I don't know.
Uh-oh. Yes, you do. What squared is 144? Think back to your times tables. What times itself is 144?
12.
12. Square root of 144 is 12. That's the missing line. So sine alpha plus beta. Use the sum identity. Sine of alpha was given to us. Cosine of beta was given to us. What is cosine of alpha?
2/5.
Because we have this 3/5. We also need sine of beta. What's sine of beta?
12. 12/13.
Now it's just a matter of actually doing this. 4 times 5 is 20. What is 5 times 13? I can't do it this way. What's 5 times 10? Oh, you should know. 5 times 10.
12/5 plus 13. 65.
5 times 13, 65. 5 times 10, 50. 5 times 3 is 15. 50 plus 15, 65. And notice, I didn't simplify it. What's 3 times 12?
36.
Oh, look at that. Same denominator. What's 20 plus 36?
56.
Which have no common factors. There's sine of alpha plus beta. So I should write that in red. Now we want cosine of alpha plus beta. Again, use the sum identity. The sum on cosine. Cosine alpha times cosine beta minus sine alpha sine beta. And we already know what sine alpha, sine beta, and cosine beta are. Right, so they're all right there. 3/5 times 5/13 minus 4/5 times 12/13. 3 times 5.
15.
Oh, look, it's the same denominator as before. 4 times 12.
48.
And again, look, it's the exact same denominator. What is 15 minus 48?
3.
Negative 33.
Oh, negative.
And again, they have no common factors. What quadrants does that put alpha plus beta in?
2.
Sine is positive, cosine is negative. That's quadrant 2. Now we're going to do sine of alpha minus beta and cosine of alpha minus beta. Procedure's the same though, isn't it? Just a different identity we're using. Here's where I get to use instructor's prerogative. Because it's all the same. All that's changing I think I want to start here. Let me do it. Good enough. And does that becomes a minus, that becomes a minus. 20 minus 36.
16.
Minus 16.
Straight up copy and paste. All that's going to change are some signs. 15 and 48.
$63.
And again, no common factors. What quadrant does that put alpha minus beta in?
One.
3.
So remember, in 1 they're both positive, and 3 they're both negative. So what quadrant is sine negative and cosine positive?
4.
Puts us in quadrant 4. Same idea. But notice alpha now is in quadrant 2, right? Beta is in quadrant 4. So technically, I can't use right triangles. But instead, if we use the reference angles, then we can. So that's what I'm going to do. Sine of alpha is 2/3, which means sine of alpha prime is 2/3. Opposite hypotenuse. What is our missing length? What's the value?
1.
What is it?
1. The Pythagorean theorem is the theorem. Square root of 11.
How'd you get 11? What's 3 squared?
Square root of 13.
And now you got 13. You did the wrong operation. What's 3 squared?
9.
2 squared?
Oh.
You want 3 squared minus 2 squared. Because we're not looking for a hypotenuse, we're looking for a leg.
Yeah, I get it.
So it's not minus 4?
5.
Square root of 5. And let's just do this now. Alpha's in quadrant 2. Is cosine positive or negative in quadrant 2?
Negative.
So cosine of alpha is going to be negative cosine of alpha prime. And what is cosine of alpha prime? Right, so just based on this triangle, what is cosine?
Square root of 5 over 3.
There's cosine of alpha. Beta is located in quadrant 4, meaning cosine of beta prime is cosine of beta. Adjacent over hypotenuse. What's the value of the missing leg?
Square root of 25.
Yeah, you did the wrong operation again.
Is so that is 16 minus 9.
7, yep. All right, so remember, you only add when it's the hypotenuse you're looking for. All right, sum of the square of the legs is the square of the hypotenuse. All right, we already know cosine beta. Beta in quadrant 4 is sign positive or negative in quadrant 4.
Negative.
All right, so sine beta is negative sine of beta prime. So now, again, just based on this triangle, what is sine?
Sine is opposite over hypotenuse. Square root of 7 over
7 over 4. We have all the values we need. Identity for sum, the sum identity on sine. Remember, it's going to be sine alpha cosine beta and cosine alpha sine beta, and the operation stays the same. Sine alpha was given to us as 2/3. Cosine beta was given to us as 3/4. We said cosine of alpha was what? Negative root 5 over 3. And sine of beta is negative root 7 over 4. That one's easy, right? 6 over 12. Again, I'm not going to reduce it. Negative times negative is going to be what? Root 5 times root 7.
Root 45.
Root what?
45.
Not 45.
So 35.
35, right?
Sorry.
Square root of 35. Well, that's just 7 times 5, right? They're both primes, so that can't be simplified. We get, how do I want to write that? Do I want to write the square root first or second? Second. 6 plus square root of 35 over 12. Cosine of alpha plus beta, sum identity for cosine. It's going to be a cosine alpha cosine beta, sine alpha sine beta. Operation switches. Cosine of alpha, negative root 5 over 3, cosine beta, 3 over 4, minus sine of alpha, 2 over 3, times sine of beta, negative root 7 over 4. What's 3 times root 5?
No.
It's a tricky
Three,
one.
three.
Yeah, it's just 3 root 5s. Or, if you want to, you could say root 45.
Okay.
Like what you're trying to do, you just have to square the 3 first. Right, 3 is root 9, so you could do that as well, root 45. I'll just keep it as 3 root 5 over 12. Now look, it's a positive times a negative, right, which is negative, minus a negative, will become positive.
On the negative 2/3.
Yeah, it's essentially a plus negative 2/3.
Yeah.
So that's essentially going to be a double negative, so it's positive. And then 2 times root 7.
2 root 7.
Or again, you could do root 28 if you wanted to. Over 12. 2 root 7 minus 3 root 5 all over 12. Now, what quadrant is alpha plus beta going to be located in? Well, sine is easy to see, right? Sine's positive. What's cosine? This is where it's convenient to use the other form. That is root 28 minus root 45. Is that positive or negative? That is negative. 28 is less than 45, so root 28 is less than root 45. Sine is positive, cosine is negative. What quadrant are we in?
2.
Alpha plus beta is located in the second quadrant. Why is my touch screen not working? I need to reset the PC. While I wait for this to load. Anyone hear the news yesterday? Oblivion Remastered Shadow dropped. I don't have any gamers now. Never heard of the Elder Scrolls 4 Oblivion. They remastered it. Dropped yesterday. I restarted playing it. Was thinking of being sick today. Think we're back. Yes, we're back. Again, constructor's prerogative, I can just copy and paste, because there's only going to be some slight differences, right? We want alpha minus beta, so we're using the difference identity. All that's changing are these signs. So that becomes minus, this is now minus. Negative times negative, you still have that, right? So that's positive, which means this sign switches to minus, which is going to make this switch to minus. Copy that down. Hopefully that will be enough time for PowerPoint to catch up. That's going to become minus, but this now becomes plus, which makes that a plus, which would make this here what? Minus, isn't it? Right, so it's now plus a 2/3 times negative 7/4. So here's how I'm going to rewrite the answer. I'm going to make that plus and put a negative out in front. Like it's now a negative plus a negative, so I might as well just back out that minus 1. So let's look at where this is going to put alpha minus beta. 6 minus root 35. Is that going to be positive or negative? It's positive. 6. Isn't that root 36? 36 is larger than 35. That makes sign positive. Cosine is so obvious. Cosine's negative. Where's sine positive and cosine negative? Oh, we're just in quadrant 2 again. Both alpha plus beta and alpha minus beta wound up being in quadrant 2. See that? questions on the sum difference identities? I think everyone did. So if you do that, turn it in to me on Monday. I'll give you +2 points on your third exam score if you get it. So derive sum and difference identities for cotangent. And again, these will be posted, the slide will be posted online on SharePoint. Your fourth quiz, this is also the last quiz of the semester, is now available and will be due Monday. And so that just covers everything since the third quiz. Again, your project is coming due as well. It's due on the last official meeting, which is May 5th. And you have 2 unassigned homeworks. We will look at the double angle, half angle, and reduction identities on Monday. Have a good weekend. I'll see you then.